Hi, hola, bonjour, xin shan wang. I'm a serious person, and today we're going to talk about abstractions. Not distractions, abstractions. And I know that in your workplace sometimes a coworker sees some abstraction and they're like, I don't like this. This is too abstract. I can't use this. And so the thing is, sometimes our head hurts when we're using these things. We're going to see these. And if your head hurts, that's okay. If you're in the gym and you're like using your muscles, right? Your muscles start hurting. So that means that you're using your muscles. So if your head hurts, it means that you're using your head. So keep on using it. And you're gonna, it's gonna stop hurting at some point, okay? So we're gonna see how these things are good. And not only are they good, but they're also fundamental in the sense that you can't avoid them. Like, even if you say, I use no abstractions, you're lying. And we're gonna show you how you're gonna use them. Like, no, how you're using them. So one of the most essential ones is the function. It's an abstraction, if you didn't know. Because before JavaScript, we had this horrible thing called goTo, where you could say here, go to line 7, and then here you would say, go to line, no wait, how, I don't even know how it would be in JavaScript because it never had it, but it would just jump all around, you know, it would just do all these jumpy stuff. So your code would start here, it would go there, and then it jumps all the way there, and then goes here, and this is horrible. And this is how life without abstraction is. So let's give a round of applause for the abstraction. Thank you. Now stop. Good. We don't have time. We need to go like, you know. So what is the function? It's I/O. Input comes in, output goes out. And today I'm going to do something that doesn't make a lot of sense, okay? Because I can't split the function in two parts, but I'm going to do that, okay? Allow me to do that. The input and the output are so fundamental in functions, but I'm going to like split them apart, and I'm going to introduce to you these two fundamental abstractions, the getter and the setter. So the getter is a function that you give it nothing, and it gives you something. And then the setter, you give it something, and it's just like, yeah, okay. So you use them all the time. I promise you they're all around in JavaScript. Like math.random, you give it nothing, and it gives you like random numbers all the time, random numbers coming out. Date.now, you give it nothing, and numbers coming out. And then you have the setter, you give it a string, and it's very selfish. It's just like, and then you're putting something on the DOM, and it's just like, yeah. It doesn't give you anything, but these are necessary for I/O. So to make something happen in your applications, you have to have getters and setters, okay? So acknowledge that. I have getters and setters in my app. Okay, so they are useful for side effects, but they are also abstractions. I'm going to introduce to you the number 10, in case you haven't seen it in JavaScript. I'm putting it as a variable, or actually a const. But then I'm doing this thing here. I'm making a getter of a 10. And of course, you can like put both of them in the console if you want, like this, console 10, and console get 10. And these two do the same thing, actually. So what's the benefit? Here's one thing. We could also write this function like this, return. And okay, yeah, sure. But now I have this space, and that's awesome. Because I could do other stuff here. I could say like console log, hi. And then every time I try to use get 10, let's say console log, get 10, get 10. And I run this in Node, let's say 04, then it says hi. So that's interesting. Every time I try to get this value, also something else happens. That's different. You can't get that with the number 10. Because even if I would move this console log there, now the problem is that I never used 10, but I actually did log out this thing, okay? So you also like have some hook for side effects. Let's say I could do analytics.sendEvent or something like that. We could also implement 10 in a different way. We could say 2 times 5. And that means, this calculation never happens in this app. Only if I call the getter will it happen. Okay, I could also write, 5 plus 5. So there's different implementations of get 10, whereas the number 10, there's only one thing. Okay, so the benefits are, as I wrote down there, laziness, hook for side effects, and implementation flexibility. All of that just by putting this getter around the number 10. So for instance, the math random, I could make my own math random because now we have flexibility of implementation. I could make my own math random. I could just say return 0.4. Well, you might thinking like that's not random, yo. But the thing is that if I call this multiple times, I mean, you're just very lucky because it's the same number all the time. You're like, wow, you're very lucky, man. And now you can have a different implementation of math random. That, you could say that your boss would complain, oh, this is not random. And you're like, what is random? Okay, so what can we do with this, okay? Let's go for it, chop, chop. I could write add for numbers like this, return x plus y. I could also write add for getters. I say get x and get y. Now I need to, get x. Oh, what are you doing there? Y. Okay, now I have x and y and I can add them. But this is wrong. Oh, not exactly wrong, but this is a bad idea because get x is an abstract number. It's living in the clouds and in the space. And y, or get y, is an abstract number living somewhere there in the clouds. But what I'm doing is I'm getting both of them and I'm adding them here in concrete world. What if I would add them in abstract world instead? And that's pretty simple. I just return a getter. So there we go. Now, this function, you could name it, let's say, get z, right? So now z is x plus y. But this is awesome because now we have an abstract number there, and we add those numbers together and we get z, but it's all in abstract world. And so far, no calculations happened. It's completely lazy. Laziness is a good thing because once something is lazy, you can make it concrete, right? You just call the getter and it's concrete. But if you have something concrete, you can't put it back in the lazy world. So that's like something that you cannot do. So we're getting flexibility with getters as an abstraction. So I can do, for instance, 10 plus random. And I can just say add get 10. And then I can say math random, for instance. And I need to still write the get 10 here. Yeah. So now I have 10 plus random. And so far, 0 calculations happened. I could make the calculations happen just by calling 10 plus random a couple of times. And if I call this, it would be different numbers. But here's the cool thing. All of these numbers represent the idea of 10 plus random. Okay? They're different instances of that idea that I pulled from the skies. That is getting fun, okay? I'm going to get to the even more fun part, where you can do these things for array items. So let's say I'll write a very simple get array item that returns, let's say, array at index 1. So I need that array somewhere here. Let's say 10, 20, 30, 40. And I need let's say start it at 0. And then I can call this thing and put it in the console like that a couple times. And now if I run it, you see all those numbers there. Oh, whoa, sorry. Yeah, we need to go forwards, right, after we output it. So this is just a way of stepping forward. So this is like a lazy iteration where, I don't need to go through all of them in a for loop, but, this is kind of like I'm going through them if I want to. Okay, but one of the problems with this is that if I keep on calling this, it just gives me undefined. And also, how do I go back to the beginning? How do I iterate over my lazy array again? So in this case, I would need to actually say I equals 0. So then, I can start all over again. But that's kind of sad, because now I have this I that's like an implementation detail of this, and I can't it's like leaking. So my problem is, how do I make this part lazy? Lazy? You guys are so lazy. So, what'd you say? Come on. You put it in a getter. You say get array item, right? That's the point of laziness. So now I have lazy initialization, right? This is lazy initialization, and I have lazy iteration. So if I want to start all over again, guess what? Oh, first I need to get array item, and then I will get array item, right? I just got that function. Now I call it a couple of times. I can say again, this equals get array item. And look at that, now I have restarting. I need to return. So this is a getter of a getter, right? It returns the getter. Good. So it says 10, 20, 30, 40, 10, 20, 30, 40. Cool. So lazy initialization and lazy iteration just with getters. That was this next step. These are my slides, okay? So my next slide is for my whiteboard. You can add the abstraction of getter on top of getters. You get getters. And those enable you to do so much stuff. And I'm gonna show you a small example how you can use these things. Let's say you make a huge array of numbers. That is a bad idea because it's in memory. It's taking a lot of space in memory. So I'm gonna make an abstract array, okay, called range from left to right, and the idea is that it's gonna have the number left plus 1, left plus 2, all the way up until right. So I'm gonna return a getter of a getter, where here I have lazy initialization, and here I have lazy iteration. So I will start, because it's initialization, I'm gonna start at left, and then I'm gonna return x plus plus, so I can keep on going forwards, but I need to stop when I reach right. So when I say if x is less or equals than right, then you can do that. Otherwise, just return undefined. So let's try giving this a go. I mean, if I call, so I'm going to call this get, and I do that, let's say 10, 15, and now I can say get, and now I can finally go through these numbers. Keep on looking at the screen, don't yawn. Yeah, so I could do this a couple of times, and I see, oh, sorry, wrong example, that would be 0, 9. I see 10, 20, 10, 11, 12, 13, 14, 15, and undefined. So, yeah, like we need to have a way of how to stop when we see undefined. Let me make a for loop for this thing, okay? It's gonna start like this, that I'm gonna first, do that part here, and then I'm gonna do x equals get. I need to check if it's done or not, so I check x is not undefined, and then go forwards. So, I mean, you've been using for loops, right? This is the beginning, where you initialize. This is your check, and this is how you go forwards. And then you say console log x, and now we can have a for loop. So then it just does that. And if you do even this, I mean, guess how many numbers I have in memory? 1. Or maybe 3 because of this is as a closure or something. But anyway, I don't have all of those numbers, and that's a beautiful thing. Beautiful, because it's not in memory. Instead, there's an array in the heavens, and I'm pulling one at a time, and my CPU is happy, and my memory is happy, and everybody's happy. So, but the problem is, what if my abstract array has an undefined as a field? That's bad, because that's my ending point. So we need to do something smarter. Let's do something smarter. Let's add some kind of special completion markers. Okay, I'll just add, instead of undefined, let's use something more smart, like an object that says done is true. And then here in this case, I'll have done is false, and value is this kind of thing. So it's like a better completion marker. And you know, like it's, like for instance, I'll just adapt this. So res will always be an object, and I need to check if res is not done. Res as in result. And then I console log res.value. So, you know, then it still works. Okay, and so you see, I still have getters, but I don't have getters of numbers. I have these objects. And I'm going to add a little bit more stuff that's not going to make sense for a while. So keep on watching, because it will make sense after I code it. But I need to just code it, because people, like, this is, yeah, well, you're going to see. So, oh, no, wait, what? Copy, paste, yeah, good. Yeah, so here in the getter, okay, I'm going to return, instead of a getter, I'm going to return an object that has the getter, okay? Simple like that. Object that has a getter. See, object, getter, okay, nothing scary, right? Nothing scary. And then instead of returning the higher getter, I'm going to return an object that has a method called symbol.iterator. Yeah. And then now, you see, it's still a getter, right? Because it's a getter, but it's just wrapped in some weird objects and stuff like that. Why am I doing that, André? Because JavaScript has a special syntax that notices symbol.iterator and next. And then instead of this crap, you can write for let x of range 10, whatever. And then console log x like that, my friend. See, so remember when I say these are unavoidable abstractions. This is what's happening when you do a let x of something. JavaScript is checking, is this thing like an object that has symbol iterator, which is a getter, which returns an object that has next as a getter. And if it detects that, then it knows, this is an abstract list. Living in the abstract world, I will give you a nice syntax for iterating over that abstract list. And this is what it is. And that is iterables. So with a little bit on top of getters, you get iterables, and it's beautiful. I mean, we are not using iterables that much. I'm going to give an example how you can detect when should you use an iterable or not in your application. Pretty often you have the situation of a for loop with an if condition. I mean, come on, everybody does this. And I'm going to tell something that may offend some people, but I mean good. This is an anti-pattern. And everybody does this, it's normal, but what we want to express is I want the numbers from 0 to 10 that are even. And I may need to be copy-pasting this if all around, when instead I could just use an iterable that already comes filtered, okay? And doing that is cheap, because if you have an array that's in memory and you filter it, right? It means that when you say filter, it will filter all those things. And then you can iterate over it. But that's not the case for iterables. I made here filter by myself. So it takes a condition, and it takes your iterable. I'll just show how we can use it. It's kind of like array filter, so I'm not going to explain it in so much details. But here I can put my condition, and then I can get rid of the if. And now it still does the same thing. It gives me even numbers. But as I said, this is very different than array filter, because essentially when I'm pulling that abstract array from the skies, it's already filtered for me, you see? And I'm basically embedding that if condition inside that abstract thing. And there's a lot of opportunities where we could do this. We could also do concat, so where instead of doing one for loop over this and another for loop around, let's say, some other thing, and doing the same console log, what you could do is just concatenate one abstract list with another abstract list, and this will cost nothing because it's abstract, okay? So there's a lot of opportunities where we can use iterables in a smart way. But now let's go back all the way, because beyond iterables, there's like async iterables, async iterators and generators, which I could take this to ad infinitum. And JavaScript supports all these things, so this is a very nice world. But let's talk about this fellow for a while. Setters, okay? I ignored them, but let's talk about them, okay? Let's go back to their number 10. And I'm going to try something that makes no sense. I'm going to say function set10. What do I do here? No, I can't do that. It's not even like, what? And then I have to return undefined here. This makes no sense. This is, okay, let's say that this would be x. Then, okay. It doesn't make sense. Do you see? It doesn't make sense. Because the setter is the world's most selfish thing. It's like a black hole. You send the number 10 into it, and it's like... So it's not an abstraction. So I kind of lied to you, and this is why you're probably not feeling well, because it's not an abstraction. But setters are an abstraction. Okay, this might break your brain. Okay, so buckle, put your seatbelts. We're gonna go like, yeah, this is gonna be fun. So I'm gonna make a setter of 10. Okay, I'll just make the setter set 10. And what does it do? It will set 10. Okay. So now I know I need to return undefined here, so I'm just gonna not have anything there. But now. Okay, I have set 10. I can call it. Set 10. Huh? Okay. Let's see. When we had the console log with getters, right? I did like this. Oops. But how do I how do I use that number which is trapped inside the setter? Do I do like set 10? No. Here's how we do it actually. We say set 10 console log. And now if this is breaking your brain, I'm going to unbreak it. So just give your brain to me. I'll fix it here. So look at that. This is easier now, right? Now you're like, oh, okay. So x is probably the number 10, right? And I'm putting it in the console log. Trust me, this will work. I mean, this is like, come on, people, look at that. This is like the simplest JavaScript. Like, I hope you understand this. Look at that, you get the number 10 in the console. But now, I can do also set timeout. And I can make that number 10 come kind of late. Right? So what do I gain with setters? Asynchronous programming. But I also gain inversion of control, because now basically I have my console log, which is my program, and like the setter is abstract somewhere there, right? Now instead of pulling down that number down to earth, what I'm basically saying, I'm taking my console log and I'm tossing it all the way up to abstract world, and I'm saying, you do whatever you feel like doing with it. And it does that. So in fact, I could, it could even like send me many number 10s, and there's nothing I can do about it. It will just send me many number 10s, right? Now, I can help your brain a little bit because you're still confused, I can see. I'll just rename this slightly, okay? I'm going to call this set10 listener. Listener. Right? Because this is familiar stuff. We have document, add, event listener, click, and look at that. That's what you usually write, right? What is this thing here? It's like a set event, right? Well, because what's the signature of it? It takes nothing. It takes the event and returns nothing, right? There you go. Setter, right? It's a setter. So setters are just callbacks. Ta-da! But you can do a lot of fun stuff with setters. There we go, setters. And as you see, we're missing the last piece. And one of the opportunities where you could, like how you could use setters is, well, similarly where we had, for instance, let me try to get that code again. I'll just write here. So imagine that you have the situation here. You add an event listener, and here's event. You've probably done this once in your life. If event.client x is less than 30, then, I don't know, do something. Okay, of course you've done something like this. An event listener that has an if, but just as I said about the iterables with an if, you could also have a filter here. So let me just first write the pure sort of, the sort of canonical setter. I'm going to call it set click, okay? And that would be a set click. And here we could just move this kind of thing inside there. Forget about this. So set click, okay? So this is my set click. And I could, of course, call it. And here's my event. And if event client x is smaller than 30, do the console log. Okay, I could use filter. So I could say, this is like a corner click because I'm clicking on the left side of the screen. So I'm going to call this set corner click, which would take set corner click. Oh, but I'm going to use the filter. I created filter here, so it's kind of like filter for arrays, where I give a condition, event client x is less than 30, and I'm going to apply that on my set click. Okay, I'll let you digest that for a while. So then I can just call set corner click. Set corner click, and I don't need this if. So look at that. What is this thing? It's called an operator. And arrays have it, iterables, you can make those for iterables. And again, this is an abstract thing. So I had there like click setter, and then I made another corner click setter. And then I took my console log and I tossed it up there to that one, into abstract land. And this is starting to look like something, okay? Because if I just wrap this function in an object, okay, just like I kind of did with iterables, and I call this subscribe, right? Like this, right? And I'll just give this a different name, like click something. Right? And this is like, well, I'll just kind of call this observer.next. And what is this, fellows? What is that? Someone recognize? Observable. So that's it. You add an object around this setter, and you add another stuff like observer.complete, that kind of stuff. And what complete gives you is the ability to concatenate So you could concatenate your streams of events. So you could have some abstract sequence of stuff in space, and you could concatenate that with another one, and then you could finally toss your side effect to the abstract land. Those were the abstractions that I wanted to talk to you about, and it all folds from getters and setters, which are, in the end, just the function. Okay? The function is the ultimate abstraction in JavaScript, which we have since day one, and it, like all of these crazy stuff at the top, are just different sort of aspects of the function. Thank you for listening.